How can we find the area of this crescent? Give this problem a try and keep watching to see the solution. We know that the horizontal gap is 18 units and the vertical gap is 10 units. Now, if we remove the shading, it becomes very clear that we have two interior tangent circles. So let's draw a horizontal line that goes through the two centers, and let's call them A and B. So A is the center of the large circle, and B is the center of the small circle. Now let's call the radius of the big circle big R, and the radius of the small circle small r. The target area is the difference between the two areas. So the target is pi r squared minus pi small r squared. So ideally, we'd want to find two equations that relate the two radii, and that will allow us to find these individual radius values, which will allow us to find the target area. So let's start by asking ourselves, how far away are the two centers? So what is the length of the line segment AB? It's very clear that this is the difference between the two radii. Okay. Now, if we use the fact that the horizontal gap is 18 units, notice that this is actually the difference between the two diameters. So 2 big R minus 2 small r should be equal to 18. Now everything is divisible by 2, so let's simplify this a little bit, and that'll give us big R minus small r equals 9. And this is precisely the length of the line segment AB. Okay, so we know that the two centers are 9 units apart. This is the first equation. Now we need to come up with a second equation. To do that, we'll have to use the vertical gap that is given to us in the question. Let's draw vertical diameters of the two circles. So we'll have the vertical diameter of the red circle and the green circle. And now if we draw this radius of the small circle, notice that we have a right triangle that can give us some extra information. The base of the triangle is AB. The hypotenuse is the radius of the small circle, and the vertical leg is actually 10 units shorter than the radius of the big circle, so r minus 10. So using the Pythagorean theorem, we can set up another equation. Now, we know that AB is equal to 9, so we can substitute that in, and from the same equation, we